Now we're moving on to evaluation of composite functions. Evaluation means to simply plug a number into the composite function. Let's say I have f of x is equals to x squared minus 2x plus 4, and I have g of x is equals to 2x minus 4. Well, and I want to get the answer to this question. What is f of g of x evaluated when x is equals to 2? Well, the nice thing is that there are actually two methods to get to this answer. So you can always work it out twice and check to see if the answer is the same. The first way is actually pretty straightforward. Simply find f of g of x and then plug in 2. So let's do that. So method 1. So we're finding f of g of x. So f of g of x, the composition of the two. And so that is going to be g of x squared minus 2 times g of x plus 4. And so that's going to be, oh boy, 2x minus 4 squared minus 2 times 2x minus 4 plus 4. And so then that's going to be equals, woof, what is 2x minus 4 squared? So off to the working column we go. 2x minus 4 times 2x minus 4. I am foiling to my little heart's content. 4x squared minus 8x minus 8x plus 16. Uh-oh, I'm out of space. That's a 16 right here. Uh-oh. And so that right here is 4x squared minus 16x plus 16 minus 4x plus 8 plus 4. Whew. And so that's 4x squared. 16 and 4 is negative 20x. 16 and 8 is 24, and 4 is 28. Gosh, that was fun. And now I have f of g of x. I can plug in 2. So f of g of 2 is equals to 4 times 2 squared minus 20 times 2 plus 28. Woo. And so that's going to be 4 times 4 minus 40 plus 28. And so that's 16 minus 40 plus 28. 16 and 28 is 28, 38, 38 and 2 and 4 is 44. 44 minus 40 is equals to 4. So f of g of 2 is equals to 4. Now that I have this function right here, I could find f of g of 5. I just plug 5 into this expression. I can find f of g. I can find f of g of 10. Just take 10, plug it into the equation. I can find f of g of negative 1. Just take negative 1, plug it into the equation. And that's the first method. Explicitly find the f of g of x and then plug the number in. The other way to work this problem out, so let me rewrite. So method 2. Again, I have my function f of x is equals to x squared minus 2x plus 4, and my second function g of x is equals to 2x minus 4, and I want to find f of g of 2. The second method for solving this problem is to do the little bunny hop. So what you do, you just gotta get an extra, you get one extra hop right here, and so you take 2 and you plug that into g. The results that you get, you plug that into f. And that is how method 2 works. So let's start at the beginning. G of 2. So you find g of 2. So that's equals to 2 times 2 minus 4. That is 4 minus 4 equals 0. So my result is 0. Now that I know that the result is 0, I take 0 and I plug that into f. And so I simply find f of 0, which is equals to 0 squared minus 2 times 0 plus 4, which of course is 4. Notice I got the same answer as before. I prefer the second method of just doing the bunny hops, plug in and then plug in again with the answer. But either method will work. In fact, both methods always work. And so it's up to you. Let's just do one more example of method 2 since it's so much fun. Let's say I want to find g of f of negative 1. So again, what that'll mean is I will take negative 1 and plug that into f. The answer I get, I take that new answer and I plug that into g. Notice right here that switching them right here results in me working the functions differently because I have f as the inside function. So what's f of negative 1? I don't know. F of negative 1 is negative 1 squared minus 2 times negative 1 plus 4. 1 plus 2 plus 4, that's 6, 7. And now I take 7 and I plug that into g. G of 7 right here will be 2 times 7. What's g? Yes, 2 times 7 minus 4. And so that is equals to 14 minus 4, and that's equals to 10. And there you go. G of f of x. Notice right here, I did not actually need to find the composite function. And so generally speaking, this method is much faster than having to find the composite function. But sometimes you already have the composite function. If I first ask you to find f of g of x, well, you already have f of g of x, might as well just plug it in and be done with it. But if it didn't explicitly ask you to find f of g of x, then the other way is just fine. Now, sometimes they don't actually give you the function. Instead, they give you the results of working with the function. So let's say I have a table of values. So let's say I have x, and then I have f of x right here. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Then I have 4, negative 4, negative 1, 3, negative 2, 0, 1, 2, and 6. Right here in this example, so far, I didn't give you the function, I just give you the results. Now this is a table of values. So a table of values comes from the function. So if I ask you to find f of negative 1, well, the table right here says when I plug in negative 1, the answer is 3. So therefore, f of negative 1 is equals to 3. So that's my first function right here, f of x. But of course, if a composite function, that means I need to have at least two functions. So I need a g function. So let's go ahead and get ourselves a g function. Extending the lines. Extend, 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 extend. Boy, isn't this fun. Negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. So I have my g of x. So again, what this table means right here is if I was to find g of negative 1, when I plug in negative 1, the result I get is 0. So g of negative 1 is equal to 0. So now that I have that right here, I can go ahead and find my composite function. Let's say I want to find f of g of 2. Well, that means I got to take 2 and plug it into g. And so plugging 2 into g, I will get an answer of 3. So now that I know that, I just find f of 3. And when I plug 3 into f, my answer is 4. And so therefore, f of g of 2 is equals to 4. Similarly, if I want to find f of negative 2, I take negative 2 and plug into f. When I plug in -2, my answer is -1. And so I take -1 and plug it into f again. And f of -1 is 3. And so my answer right here is 3. Alright. Well, thank you.